Okay, here are your notes for Sig Figs. A couple things you need for these is accuracy and precision. They're in your vocab, so you don't need to write them again. Just know what they mean. So real quick, I'm just going to give you a visual. Accuracy is whenever they all go to the bullseye or the correct answer, either way. So all these darts would be accurate. Precision is they don't necessarily have to go to the right answer or go to the bullseye, but they do have to be repeatable, which means they all go to the same spot. So this picture would be precise but not accurate. This picture would be precise and accurate since they're in the bullseye. And then this picture would be neither. This is not precise, nor is it accurate because it's not on the bullseye. Um, we're not going to do that yet. Okay, so significant figures, basically what it is, we use significant figures in science to show the accuracy of our devices. So our graduated cylinder or our ruler, how many sig figs we show is how accurate that device is. So for instance, if we had a ruler and I showed this measurement as 6.35. Well, 6.3 is definite because I have a 6 hash mark and I've got 3 hash marks, but the 0.5 is an estimated digit. So this has 3 significant figures, and it is showing that my ruler is accurate to 2 decimal places. So that is the purpose of significant figures. You have these rules already on the handout that I gave you. You can use that on Friday. So you probably don't need to write this down because you already have those. Now, I will say that we're going to do this real quick so I can show you. I want you to take out a piece of paper, and you will need to turn this in for me. And I want you, on these problems, I want you to tell me how many each one has, how many sig figs each one has, and what rule applies to make you think that. Remember, you have those rules on your handout, okay? I'm going to do this one because it's one of the harder ones because you haven't seen many with these decimals. Without this decimal, this number, I'm doing this one right here. Without this decimal, this number would normally have 3 sig figs because we don't count trailing zeros with no decimal. But when they put this decimal here, like they did, it then makes them all significant, okay? So this one has 4 sig figs, and it's because trailing zeros count with a decimal, not without, okay? So with a decimal, they count. Without, they do not. All right, so that is why it has 4. So for each one of these, A, C, D, and E, I want you to take the time to tell me how many sig figs it has and what rule applies. And some of them may be more than one, this one. So make sure that you tell me all the rules that apply as well. The other thing that I need you to do is do these scientific notation problems here. I need to know that you can do these. I want you to put these 2 into scientific notation and take these out, okay? So I'll do you a quick example over here. If I have 7, 800, okay, I wanted to put that into scientific notation. The decimal's understood to be at the end of the number. I would go 1, 2, 3. You stop moving when there is only one number to the left of your decimal, and you would write it like this. It's going to be a positive exponent if you're doing a big number. And if you're doing a small number, I'll do an example over here. You would move the decimal, same thing, until there's only one number to the left, and then you would write it 4.5. But this time, your exponent would be negative. I moved it 1, 2, 3 times, -3. Okay, so also take a minute and do these 4 problems right here. Turn this sheet into me with the sig figs and the scientific problems on it. These will be your class problems for today.